May 2018 AS Applied Paper Question 7. A train travels along a straight horizontal track between two stations A and B. In a model of motion, the train starts from rest at A and moves with constant acceleration of 0.3 meters per second squared for 80 seconds. The train then moves at constant velocity before it moves with constant deceleration of 0.5 meters per second, coming to rest at B. For this model of motion of the train between A and B, state the value of the constant of velocity of the train. So what we know is that it accelerates for 80 seconds at a rate of 0.3 meters per second. So if we do 80 times 0.3, we get 24, and that's what it reaches, 24 meters per second. For part 2, state the time which the train is decelerating. So we know that it starts at 24 meters per second and it decelerates at a rate of 0.5 meters per second before it comes to rest. So we're at 24 and we are decelerating at 0.5 meters per second, and so that is going to take 48 seconds to come to rest. Part 3, sketch the velocity time graph. So what we know is that we start off at 0, and then after 80 seconds we get up to our speed of 24 meters per second. We then go along at a constant speed and we then decelerate. So this can be at time t, and this is going to be at time t plus 48 seconds because that's the time it takes to decelerate. Part B, the total distance between the two stations is 4,800 meters. Using the model, find the total time taken by the train to travel from A to B. So, looking at the model that we've got, we can split this up into 3 separate parts. So we've got a length here of 80 seconds, we've got a height of 24. This is going to be a total of t seconds between 80 and whenever, and then we know this end part is going to be 48 seconds. So what we know is that the total area under the graph is 4,800 meters because that's the distance traveled, and that is equal to a half times base times height for the triangle here. Add 24 lots of t for the rectangle here. Add a half times the base, which is 48, times the height, which is 24, for the end triangle here. So therefore we have 4,800 equals 960, add 24t, add 576. That gives us a t value of 136. So if the t value is 136, we then need to say 80, add 136, add 48. For the total time is 264 seconds. Part C. Suggest one improvement that could be made to the model of the motion of the train from A to B in order to make the model more realistic. So we could have the train may not accelerate or decelerate uniformly.